In October of 2017, something truly extraordinary happened. For the first time in recorded history, astronomers detected an object entering our solar system, not from within, but from the vast unknown of interstellar space. It was moving too, fast and along a trajectory that made it clear this was not an ordinary solar system visitor like a comet or asteroid. This was something else, something foreign. They named it Oumuamua, a word from the Hawaiian language that translates to scout or messenger from afar. The name was fitting. From the moment it appeared, Oumuamua became one of the most mysterious and hotly debated subjects in modern astronomy. Right away, scientists noticed that this object behaved unlike anything we had encountered before. For starters, its shape was incredibly elongated. Unlike most natural space rocks, which tend to be spherical or irregularly shaped, but not quite like this. It resembled a giant, tumbling cigar or a flat pancake, depending on how you modeled it. Even more puzzling, as it passed by the sun, it didn't behave like a comet. There was no tail, no glow of vapor or dust that typically follows a comet when it nears a star, and yet somehow it accelerated as it moved away from the sun. An effect that couldn't be explained by gravity alone. The absence of visible outgassing left scientists with more questions than answers. Since that moment, Oumuamua has stirred up every kind of hypothesis, from the plausible to the provocative. Was it a fragment of hydrogen ice that sublimated invisibly? Could it have been a shard of a shattered exoplanet? Or, as some speculated, was it something more artificial? A defunct probe? A light sail from another civilization? Despite intense scrutiny, no single theory could satisfactorily explain all of its peculiar features. The mystery only deepened as it continued its journey out of the solar system, beyond the reach of most telescopes, until the James Webb Space Telescope entered the picture. Launched in December 2021, the James Webb Space Telescope, or Webb, as it's often called, was built to answer the universe's deepest and oldest questions. Unlike any telescope before it, Webb can observe in the infrared spectrum, allowing it to peer through dust, detect faint heat signatures, and see the otherwise invisible details of the distant cosmos. When scientists pointed Webb's powerful instruments toward the now distant Oumuamua, they finally captured something that astronomers had waited years to see, the first real image of this enigmatic traveler from another star. What they saw was staggering. Webb confirmed what scientists had previously only been able to guess at through calculations and models. Oumuamua has an elongated, asymmetrical shape, far more extreme than any asteroid or comet ever recorded. Its surface is heavily marked, pitted with grooves and craters that tell the story of a journey through deep space spanning billions of years. These surface features alone revealed how long it had been drifting through the galaxy, bombarded by cosmic rays, micrometeoroids, and radiation. Even more intriguing was its composition. Webb's sensitive instruments detected materials on its surface that are incredibly rare in our solar system. There were complex organic compounds, molecules that contain carbon and are often associated with life, as well as mineral and metallic elements that don't match the typical composition of solar system bodies. This indicates quite clearly that Oumuamua was born in a star system very different from our own, a place with unique conditions and chemistry, perhaps younger, more volatile, or richer in specific elements. The implications are profound. Not only is Oumuamua from another part of the galaxy, but its makeup tells us about the diversity of planetary systems across the Milky Way. But one mystery still lingered. Why did it accelerate as it left the solar system? With no visible signs of gas or vapor pushing it, scientists had to rule out traditional explanations. Instead, Webb's observations led to a surprising new theory, one that involves an exotic propulsion mechanism. Some researchers now believe the acceleration could be caused by radiation pressure, an effect in which photons from the sun exert force on an object. If Oumuamua were extremely thin or reflective like a solar sail, it could, in theory, be pushed by sunlight. This idea has long been a staple of speculative space travel, and its presence in nature, or via artificial design, raises major questions. Further analysis of the light reflecting off Oumuamua revealed something just as fascinating, a highly reflective material embedded on its surface, which might explain its odd brightness and unusual motion. Webb's instruments also detected chemical signatures, suggesting that this object might have formed in a highly active, dynamic young star system, one where violent forces shaped planets and tore them apart. In fact, one of the leading new theories suggests that Oumuamua could be a fragment of a planet destroyed by the gravitational forces of a nearby black hole or massive star. Such a catastrophic event could stretch and shred a planet, sending fragments hurtling into interstellar space. If true, then Oumuamua isn't just a rock from another solar system. It's a relic of a planetary system that no longer exists. A survivor of cosmic destruction, carrying clues about how star systems live, die, and evolve. And remarkably, it may not have come alone. Objects like it could be more common than we think, drifting silently through the galaxy, waiting to be discovered. The discovery of organic compounds on its surface adds another layer of intrigue. Could Oumuamua be a carrier of life's building blocks? Could it be part of a natural process that seeds star systems with the ingredients necessary for life? This concept, known as interstellar panspermia, proposes that life, or at least the raw materials for life, might be scattered throughout the galaxy by comets, asteroids, or interstellar fragments like Oumuamua. If so, then this object could be one of many messengers, silently helping spread the potential for life from one system to another. In that sense, Oumuamua is more than an astronomical curiosity. It's a time capsule, a piece of a distant world shaped by forces and events we can barely imagine. Its passage through our solar system gives scientists a rare opportunity to study the processes that govern the universe on a grand scale. From star formation to planetary destruction, from the chemistry of alien systems to the mechanics of interstellar travel, this one object touches nearly every corner of cosmic science. The findings from Oumuamua also lay the foundation for future missions. With its unique characteristics now better understood, space agencies may one day launch spacecraft designed to intercept similar objects, study them up close, and perhaps even collect samples. These missions could answer some of the biggest, open questions in science today. What kind of star system did Oumuamua come from? Are objects like it common or rare? And could they really carry the seeds of life? For now, what we know is that Oumuamua has shaken our understanding of the universe. It's reminded us that the cosmos is still full of mysteries and that our solar system is just one small part of a vast, interconnected galactic ecosystem. Whether natural or artificial, whether a fragment of a dead world or a piece of alien technology, Oumuamua has already changed how we think about space, life, and our place in the stars. Its journey has also inspired a new wave of interest in interstellar exploration. Projects like Breakthrough Starshot, which aims to send ultralight probes to nearby stars at a fraction of the speed of light, have gained momentum. The possibility of encountering more objects like Oumuamua, perhaps even studying them up close, now feels more real than ever. In the end, Oumuamua is more than an object that passed through our solar system. It's an open invitation to imagine, to explore, to question. It's a reminder that although we are small, our curiosity is limitless. The universe continues to surprise us, and Oumuamua, the interstellar messenger, is just the beginning of what's out there. What secrets still lie hidden in the dark spaces between stars? Only time and our relentless pursuit of knowledge will reveal them.